continuing with solving exponential equations. You might be given one that looks like this. If this is the case, if you'll view these as trinomials that need to be factored, and instead of looking at it like this, just look at it as e squared minus 4e plus 3. We'll go back and put those x's back in just a minute. Now I'm going to take this equation and factor it. So it factors into two binomials. Looking for factors of 3 that would combine to give me 4. So that's going to be negative 3 and negative 1. So now I have two equations. E minus 3 equals 0 and e minus 1 equals 0. Now I can go back and put those x's on. There were two of them, so there's one here and one here. So one in each place. And now I can solve these equations separately. So I'm going to move the, remember you isolate the exponential piece, so move the 3 over and I have ex equals 3. And this one will be ex equals 1. Now I can do natural log. So I'm going to do natural log of e to the x equals 3. And on this one, I don't even have to do the natural log. You could, but you don't even have to bother because anything to the 0 power equals 1. So e to the 0 power equals 1. So I know already that x is going to be 0. On this other equation, the whole point in writing the log base, natural log of 3. The whole point in writing that is to pull this down to the front. So I now have x log e equals log 3. Remember, log base e of e. Anytime you have same bases and arguments, I'm left with x equals natural log 3. So I actually have two answers to this problem, x equals 0 and x equals natural log 3. Now occasionally they'll give you one that actually has, similar to that, is going to look like this, e to the 4x plus 5 to the 5e to the 2x minus 6. And you're going to think of that the same way. Think of that as e to the 4 plus 5e squared minus 6, which will factor as x plus 6, e plus 6, and e minus 1, which I can set up as two separate equations. E plus 6 equals 0 and e minus 1 equals 0. Now when I go back and put my x's on, this time it's going to be 2x and 2x. And then we just solve from there just like we've done on the previous problems. So this is going to be e to the 2x equals negative 6. I have now isolated my exponential piece, so I can put in the natural log at this point. So I'm going to have natural log e to the 2x equals negative 6. Natural log e to the 2x equals 1. This piece moves to the front. So I have 2x natural log e, 2x natural log e. Natural log of e cancels. Divide both sides by 2. And on this piece I get x equals negative 3. And on this piece I get x equals a half. Now, careful here because, actually on this one I think this is fine. Because we're not actually taking a logarithm. So I actually have two answers on this one. I have x equals negative 3 and x equals 1/2. Okay, so now let's solve a logarithmic equation. We've been solving exponential equations, so this is going to be solving logarithmic equations. In order to solve a logarithmic equation, you're going to be given something like this, log base 4 of x plus 3 equals 2. Now in this case, all you have to do to solve this logarithmic equation is rewrite it as an exponential. Remember, the base becomes the big base. The answer becomes the exponent, and the argument becomes the answer. And then from here, you just work this out. So 4 squared is 16. Subtract 3. So that was fairly easy, solving that logarithmic equation. Of course, they get a little bit more complicated. So let's do one that's a little bit harder. This one's actually quite a bit harder, but of course, the ones that the computer asks you to do are always a little bit harder. All right, in order to solve this logarithmic equation, you are going to have to rewrite it as an exponential. But in order to rewrite it as an exponential, you first have to condense it into one log. So that's your first order of business. Condense to one log. So right now I've got logs on both sides. So in order to condense it to one log, I need to get them all together. So I'm going to move this piece over. So now I have natural log x plus 2 minus natural log 4. That shouldn't be 4 plus 3. That should be 4x plus 3. Minus natural log of 1 over x. And that equals 0. Now that I have them all on the same side, I can condense it into one logarithm. Now notice I have subtraction here and here, which means both of these are going to be on the denominator. So I have 1 log. X plus 2 is going to be on the numerator, and on the denominator I'm going to have both of these pieces. They're being multiplied by each other down there, so it doesn't matter what order you put them in. So I'm going to put the 1x in front. And that equals 0. So now I have rewritten it into one logarithm. I'm going to go ahead and simplify that logarithm a little bit before I make it an exponential by distributing the 1x. So now I have natural log of x plus 2 over 1 over x times 4x is just 4, because the x's will cancel, plus 3 over x. So all I did was just simplify that, just by distributing the 1x into the 4x plus 3. All right, now we're going to rewrite this as an exponential. Don't forget, natural log is log base e. So I really have a base of e here. So my base becomes my big base, my answer becomes my exponent, and my argument becomes my answer. So now the word log is gone. So now I can solve this. Remember, e to the 0, anything to the 0 power is 1. So e to the 0 is 1. And now all I need to do is clear this fraction over here to make this easier to solve. So in order to clear a fraction, you multiply by the denominator. So I'm going to multiply both sides by 4 plus 3 over x. Because of the 1 over here, that makes that easy. These cancel. I have 4 plus 3 over x equals x plus 2. Now I still have a denominator that I would like to clear and get rid of. It's that x. So I'm going to clear that by multiplying both sides by x. So now I have 4x plus 3. It cleared that denominator, which is exactly what I wanted. And I have x squared plus 2x. Now anytime you have x's and x squareds in the same problem, you're going to have to move everything to one side and factor. So I end up with x squared minus 2x minus 3. I can factor this. Factors nicely. X minus 3, x plus 1, which means x equals 3 and x equals negative 1. Now, here's where you have to be cautious, because back at the top, it was asking me to take natural log of 1 over x. And if I plug in natural log of 1 over negative 1, I am taking a negative log, and that's not possible. So that means this is not an answer, only this one. All right, that should be about all you need for 4.3 and 4.4.